Good afternoon, and thank you for your attention. I'm happy to be able to share some of the work we're doing down at the Napatree Point Conservation Area as part of this session about lessons learned from storms. Napatree Point, as we'll find out, is a largely undeveloped barrier, and you see minimal management in terms of things like beach replenishment. We've been monitoring down there since before Sandy using airborne LIDAR and field surveys going back to 2013, measuring both the impact of the storm and the response since Sandy. Big shout out to the previous speaker, Eve from the Army Corps, for getting me access to the 2018 LIDAR data ahead of full public release while I was home this spring going stir crazy without a lot of field work that allowed me to fill some time and work on a lot of the data that I'm sharing with you today. The Napatree Point Conservation Area is located in southwestern Rhode Island, right on the border between Rhode Island and Connecticut, at the confluence of Block Island Sound and Long Island Sound. Napatree itself is the southern boundary for the Little Narragansett Bay estuary, which is where the Pawcatuck River drains into, which has a watershed of basically the southern 1/3 of Rhode Island. Sandy Point, pictured there as the small barrier island heading towards Stonington, Connecticut, is an interesting story. It used to be connected to Napatree Point prior to the 1938 hurricane, but we're going to have to bypass that for time right now. Napatree is a welded barrier connected to headlands at both the east and west ends. The Clumps End Moraine forms Napatree Point here at the west end, and the Watch Hill headland at the east end. Both are made out of a diamict. It's glacial till. It's a mixture of silt, a little bit of clay, sand, and gravel going all the way up through boulder sized. The Watch Hill headland, shown on the right, is largely armored with both seawalls and revetments. It's a pretty posh summer community. I've highlighted Taylor Swift's summer mansion there for scale. The barrier consists of a pretty typical single Foredune ridge system. You see the east end has a fairly high Foredune, 6 to 7 meters above mean low or low water. The west end of the barrier is much lower, average post-Sandy Foredune elevation below 4 meters relative to mean low or low water. Why do we care about Napatree beyond being just a beautiful place to go do some field work? It attenuates storm impacts for the southern end of Little Narragansett Bay and the adjacent shorelines of Stonington, Connecticut, and westerly Rhode Island. It's unmanaged, and what I mean by that is it's got minimal use of sand fencing and no beach replenishment. Now, why I say that showing you this slide is a little bit ironic, but once you get away from the eastern end of the barrier where you cross over what we call the Big Dune, you don't see a lot of sand fencing out on the barrier itself. And since 2013, they've largely phased out the use of traditional sand fencing, opting for split rail cedar fencing to direct people instead. It's also essentially a closed system with minimal, if any, sediment input from adjacent areas. It provides unique habitat for a number of threatened or endangered species, including piping plovers, American oyster catchers, and least terns. It's not unusual to see in the last couple of years doing field work in the late summer or fall, 3 or 4 dozen American oyster catchers gathered around the lagoon on the western side. It's a conservation area, but it remains an important recreational area with hundreds of visitors a day in the summer, exceeding 1,000 at times, coming in either by foot or by boat. And as the manager, Janice Sassy, likes to say, her job is to keep Napatree from being loved to death, balancing the conservation with the human use. And Superstorm Sandy, what we're focusing on with this presentation, is the single most significant storm measured as storm surge to impact the area since the hurricane of 1954, Hurricane Carol. In southern New England, Sandy was predominantly a wave and surge event. Wind speeds peaked at 20 meters per second in a slightly offshore direction at the peak of the storm. Peak storm surge was 1.4 meters above mean high water, and offshore wave heights measured at the Block Island buoy, 50 kilometers southeast of Napatree, is about 9.5 meters. We don't have reliable nearshore data, except during Tropical Storm Irene on the adjacent South Shore. they measured waves exceeding 4 meters in about 7 or 8 meters of water depth. We assessed the changes at Napatree using a combination of field and lab techniques. We have profiles measured with RTK GPS. These are done quarterly as well as after storm events. We have digital elevation models that we can compare that were extracted from airborne LIDAR. This includes 2011, which serves as our pre-storm. We have 2012 post-Sandy LIDAR collected for the Army Corps of Engineers, 2014 and 2018 LIDAR. From that LIDAR, we extracted profiles every 50 meters along shore. And from those profiles, we can pull out various metrics, including profile volume, dune crest, dune height, and as well as the various changes between those subsequent years of LIDAR. Field observations following Sandy showed a mixed response on the barrier. The western half of the barrier was largely overwashed, and there was fairly significant deposition for washover fans. The eastern half of the barrier, where the foredunes were higher prior to the storm, saw more frontal erosion, more of a collisional response in the parlance of Salinger and others. The dune crest retreated on average 4 meters from its pre-storm position with a maximum retreat of 13 meters. In those transects, the dune was basically removed. The far east end outside of the conservation area, there's a set of beach cabanas. The foredune that was underneath those cabanas was deposited in the parking lot and into adjacent Watch Hill Harbor during Sandy. That was subsequently excavated and returned to the beach. Profiles extracted from the pre and post Sandy LIDAR showed the change to the morphology of the barrier. In both of these slides and all my subsequent images, red represents erosion, green represents deposition. In this case, we see largely removal and retreat of the primary foredune. We see deposition of a washover fan on the bay side, the left side of your image. And we see berm deposition following Sandy, which was not atypical based on our work along the Rhode Island South Shore. Near the east end of the barrier, where the dunes are a little taller, we see more of a scarping response. The barrier narrows rather than significant deposition of any washover fans. The shoreline position, measured as the last high tide swash in low wave energy photographs in June of 2012 and a field survey in June of 2013, shows that the western half of the barrier and Napatree Point shows essentially no change in shoreline position within the uncertainty of the methods. The eastern half of the barrier, though, you see the red shoreline from 2013 is landward of the blue 2012 shoreline, in some places by as much as 10 to 12 meters. By superimposing the pre and post-storm LIDAR, we were able to look at changes in elevation and calculate volumes between these surfaces, and red again represents erosion, green represents deposition. And we see largely the left half of the barrier, the western half, is showing some overwash. Now the lighter green is not continuous because I'm only showing changes greater than 20 centimeters, plus or minus, to remove the noise and some of the uncertainty. You see less overwash and washover fan deposition on the eastern half of the barrier, with the exception around a few of the smaller dune crossovers where we see some deposition on those paths. The washover fans near the western half, near that lagoon, are visible here in these 2013 oblique aerial photographs. When we look at the morphology of Napatree as a whole, we see this trend of increasing dune height as we go towards the east, really apparent on this graph. This is the extracted dune crest elevation from LIDAR data, so taken right from the surfaces, every cell or every meter as you go along shore. You see a general increase in dune height as you go from west to east. And I've kind of drawn a line here at 1,000 meters along shore where you go from an average dune height of about 3.1 meters to about 3.9 on the east end relative to mean high water. Why I drew that boundary, or why I'm indicating those averages there, I'll show you in a minute. When we look at the changes following Sandy, we see that west half of the barrier lowered considerably. And in some cases, it went below the stillwater elevation of Sandy, suggesting that it was actually into the inundation phase, not just overwash phase of Salinger of 2000. Looking at the same area in 2014 and then 2018, we see the recovery of the barrier. At the east end, we're largely exceeding the original dune height. At the west end, we haven't quite caught up in at least part of the barrier to being above the black line, which would be 2011, but we're getting closer along much of the barrier. If we think about the response of the shoreline, we can see it here in two different places. We've got overwash regime highlighted in gray for basically 1,000 meters of the barrier. The eastern half, much more collisional. There are a couple places where the surge penetrated via the walking trails, the dune crossovers. However, that was pretty minor in the grand scheme of things. Monitoring the recovery from Sandy began with profiles in the summer of 2013. This animation takes us through all of the plotted profiles from 2013 through 2019. And what you'll notice is the increasing elevation of the back dune and the foredune. But I want to draw your attention to focus on the area around the primary foredune and the dune ramp under that highlighted area. What you'll notice is as we get towards 2018, 2019, and specifically into 2020, is when we really start to see the development of the incipient dune in front of the primary foredune. You can still actually see the dune scarp there going back to Sandy. The barrier here has narrowed as you look at the Little Narragansett Bay or Bayside on the left of the image. That's due to some erosion of the welded spit that used to enclose that small coastal pond on the west side of Napatree. As that spit's eroded away, the barrier here has narrowed considerably in the last 7 years. The recovery was well evidenced by a particularly windy storm event that was captured on two profiles 10 days apart in October of 2019. Max wind speeds in this event exceeded 23 meters per second, and the sustained winds for about a 6 to 8 hour period occurred at a lower than predicted high tide, meaning more of the beach was exposed at low tide but also at high tide. And that velocity is well above the critical velocity for the grain size, and even that's a slightly conservative estimate of grain size here. This video gives you a little bit of perspective of what the conditions were like. This was a pretty minor storm as far as the wave impacts, but you can see from the Ammophila there, it was a pretty windy day, getting sandblasted out in the field. The profiles collected before and then the day after that windstorm showed the deposition of about 3/4 of a meter, cubic meter of sediment on the three profiles on the center and eastern half of the barrier. You see berm erosion there, pretty typical for a small storm here, about 10 or 11 cubic meters of sediment lost. But notable is that increase in dune volume on that incipient foredune. That incipient foredunes continue to grow over the last year or so that we've continued to monitor that. We see a similar response at profile 2. You see growths of the foredune and almost the same berm volume lost temporarily. That swash regime of Salinger would suggest, of course, that's back within a few days. Looking at the barrier as a whole from airborne LIDAR, and this is focused on the middle portion of the barrier between the groin and the western headland, we see no significant change in volume pre and post Sandy. And that's probably due to the 2-week lag in the storm and when the post-Sandy LIDAR was collected. The berm and the intertidal parts of the beach were largely recovered, so we don't see an overall change in volume. But parsing it out by elevation, we see a drop outside of the uncertainty in parts of the barrier above 2 meters and 3 meters here above NAVD. We then see a steady increase in the higher portions of the barrier in terms of volume, both above 2 meters and above 3 meters, and right on the edge of the uncertainty for above 4 meters of elevation. You'll notice not much change between 2012 and 14. There does seem to be a several-year lag here before the vegetation, particularly on the front of the eroded Foredune, to recover. It took 3 or 4 years for that vegetation to really come back in a big way, and that is trapping now that sand on the incipient foredunes we saw in that October windstorm of last year. So I think I'll leave it there for time. I'm just over my 15-minute mark. You can contact me with any questions about this, obviously my email address or social media. This is ongoing work. We're still working down at Napatree, still examining how the barrier responds to these storm events, and I'm happy to chat about it if you have any questions. I'll give final credits here to this picture taken by Ayla Fox of Shedlight Creative. She's done some video work down at Napatree for various documentaries, but this is a pretty beautiful shot to end with. So thank you for your interest and enjoy the rest of the conference.